Okay, so let's take a look here. We're going to go ahead and find the area bounded. This is number 6, by the way, in the calculator section. We're going to find the area bounded by the graphs of y equals sine of x squared and the parabola 1 minus x squared. Now, we're using a calculator, so I already graphed them for you, as you can see, and we're looking for the area bounded between them. We do have to find where they meet. Now, in order to do that, we're going to go to Menu, Analyze Graph, and we're going to look for the intersection. And my lower bound, I might call, we'll take right here. And my upper bound, also if I scroll over, takes a while, these are some hard functions here. I hit enter, and it gives me negative 0.714. It's kind of hard to see there. So I know it's going to be at negative 0.714. Now the function is symmetric, so I don't need to really use the calculator to get the other one. Now, for part A, we're looking for the area. So, to get the area here, I'm going to drop my rectangle. I'm going to keep it in terms of x. And there's my rectangle here. I blow it up. It's dx wide. And to get the height of my rectangle, it's going to be top minus bottom. The top being the parabola, 1 minus x squared, minus the sine function, sine of x squared. So, my integral to get area, if I multiply them together, 1 minus x squared minus sine of x squared dx. And I multiplied that, and that's giving me the area of my one rectangle. Sorry about that. And I'm going to integrate that from negative 0.714 to positive 0.714. Now, there are two ways you can do this on the calculator. One, the calculator does give you an option. The calculator does give you an option, if you want to go to 6, Analyze Graph, to find the area between bounded curves. So I'm not going to do that. I'm just going to go to the home screen and go Menu, 4-2, just using the calculator here, from negative 0.714 to positive 0.714, and I integrate that, plug in my integral, 1 minus x squared minus the sine of x squared and dx. Hit enter, and I get 0.947. Very nice to do. Now for part B, is the one that a lot of people have a hard time with. This is our cross section right here, so be very careful. In this case right here, they're talking about generated when revolved about the line. This is our revolution. C is our cross section. So for part B is actually our volume. We're revolving about the line y equals negative 1. So I'm going to go ahead and sketch it out again. Here's a little function here. This is really the only part I'm looking for right here. And I'm looking at y equals negative 1. There's my axis of revolution. And I drop my rectangle. It's going to be perpendicular. Now I could do a shell method, but that'll make it complicated. You cannot have two different integrals, but this one I can only do one. And I'm going to use, this is going to become our washer. So if I draw out the washer here, dx thick, there's y equals negative 1. To get the radius of the outside, be careful, top minus bottom. Here's the outside. The top is my parabola, so it's 1 minus x squared minus a negative 1. Be careful, top and the bottom is at negative 1. So this is just 2 minus x squared. To get the radius of the inside, that's this hole here, the inside, again top, which is my sine of x squared minus a negative 1. So I get sine of x squared plus 1. And now I'm just going to find the volume, which we're pretty good at doing this now. So the volume is just pi times the radius of the outside squared minus the radius of the inside squared times the thickness, dx. And we integrate that from, and again we're going to go from negative 0.714 to positive 0.714. And we just type all of that in our calculator. Now, because of time, I know you guys are getting kind of bored listening to me. I'm just going to give you the answer there. If you type all of that in your calculator, you get about 8.924. Now, for part C is our cross section. So for the cross section, in this case right here, we're talking about an isosceles right triangle. Okay, it's perpendicular to the x-axis again. So if I kind of sketch this out, there's our area. There's that sine squared. Here's that parabola. I'm looking for this region. It's a cross section that's a right triangle. So now, but this time we have the leg in the region R. So there's my base. So if I write out my base of my cross section, it's going to be dx thick, and we know the height already. We just got that from part A. That's just 1 minus x squared minus sine of x squared. Whoops, not sine of x. Sine of x squared. Now it's an isosceles right triangle, and that's a leg. So if it's an isosceles right triangle, this is what it's going to look like. Here's our base, 1 minus x squared minus sine of x squared. Well, if it's an isosceles right triangle, those two legs are the same. So the area is just going to be, of my triangle, my face here, the area is just going to be 1/2 the base, which is 1 minus x squared minus sine of x squared, times the height. Because remember, the area is 1/2 base times the height for a triangle. But this time the height's the same. So I can just square that. Now, to get the volume of our cross section, we're going to take that same area, 1 minus x squared minus sine of x squared, multiply that by dx. And that's going to give me the volume of this cross section, because remember, it's dx thick. And I just integrate that, keep the 1/2 on the outside, it's a constant, from negative 0.714 to positive 0.714. And again, I'm going to help you give you the answer here real quickly. If you integrate this, whoops, never mind, my answer got deleted, so let me do this again. So let me go ahead and clear all this out. So I'll go and do this. Menu 4.2. I just type all of this in. Be careful, parentheses. I'm going to go from negative 0.714 to positive 0.714. And this becomes 2 parentheses. So I go 1 minus x squared minus the sine of x squared squared dx, enter. Now don't forget, I have to take that, I take 1/2 of that, 0.7562, and we get 0.3781, and there's our volume. And that's not focused very well, sorry about that. There we go, give that a second to focus, and you can kind of get your answer here. So there's our cross-sectional area there. So we did 2 problems together. Work on these, okay? And I'll see you guys Monday. Bye-bye.